For our project, we attempted to use the crowd as a subjective fitness function for a genetic algorithm. We will cover the website, mutation algorithm, and findings in this video. This is the website where we're going to be hosting the evaluations. Mechanical Turk workers will be redirected to the Evaluate Generations page. Once the citizen loads, the worker can interact with the artifact by clicking on it at random points for as long as he or she likes. When the worker is done interacting with the artifact, they can click Finish and submit a subjective rating on a scale of 1 to 3. After submitting the evaluation, the worker will receive a confirmation code from the server. This code can be entered into Amazon Mechanical Turk to receive compensation for the task. We used Amazon Mechanical Turk to crowdsource the evaluation process. The hit gives the worker a link to the evaluation page and tasks the worker with performing 4 evaluations. The original hit was unclear, and therefore the workers often failed to complete all 4 evaluations, as you can see here. After revisions to the hit explanation, the completion rate improved. We also added an optional comment box and received interesting feedback. This feedback helped us improve the hit. For example, we raised the payment amount after being advised by a worker that it was too low for the amount of tasks that we were asking them to complete.
We will now show you the best 4 to 5 citizens of each generation while describing the mutation process. For each evaluation, we gathered data denoting the number of clicks, location of those clicks, and total time spent on the animation, in addition to the subjective rating. When all the citizens of a generation are evaluated at least 4 times by the workers, we kick off the mutation process to generate the next batch of citizens. The fitness of a citizen is currently evaluated as the average of its subjective rating collected from all the workers. During mutation, we keep the top 20% of the previous generation unchanged and forward it to the next generation. The next 40% is generated by mutating the top 20% of the previous generation. The remainder of the population is filled with newly generated citizens. The purpose of the genetic algorithm is to gradually improve the quality of the artifacts according to a fitness function. In this case, the fitness of an artifact is the evaluation provided by the crowd worker. If the algorithm works, we should expect the top artifacts in the population to be improvements upon those of the last generation. We can see here that some kinds of artifacts are consistently given top ratings. We also notice the winners in the later generations exhibiting some traits more clearly than in earlier generations. Distinct animation patterns, long periodicity, and balance between order and chaos.
This is the distribution of average evaluations for the first generation. We can see it is roughly centered just above the middle of the possible range. Over the subsequent generations, we see a gradual shift in the distribution. Remember, in each generation, the lowest scoring artifacts are discarded and replaced with newly initialized random artifacts. Therefore, it is the top fraction of the population in which we should see improvement over time. And we do. Yeah! We also collected secondary fitness metrics, number of clicks, and time spent playing. We see a rising trend in these metrics as well for the top section of the population over generations. As a sanity check, we compute evaluation agreements among workers for each artifact, displayed here as heat maps, darker green representing closer agreement. We compare the agreement distribution versus random simulated agreement allocation to confirm that the quality evaluations are not arbitrary. Our project demonstrates a method for using crowdsourced evaluations to evolve interactive animated graphics along a subjective aesthetic measure. While it seems that other metrics such as clicks and time spent also increase with evolution, we have yet to incorporate them effectively into the fitness function. In the future, we would also like to experiment with generating different kinds of artifacts such as puzzles and games.